Добрый день, everybody. Hi, my name is Kishi, and I'm coming from Belgium. I'm a front-end developer. I'm working for a company called Emakina. It's a communication agency. And today I'm going to talk to you about the DOM particle system. The reason why I'm doing this talk is web integrators are doing CSS transitions to improve the user experience of their website. And sometimes I think that if we add some random animation, it could improve this user experience, you know, and the website will be more dynamic, and the user will not, you know, get use of those animations you have. And this is what it will be about. So that's why I've chosen particle system. It's because you will have random animation going everywhere, and most of the users like that, you know. And it is not a fight about DOM versus canvas, not at all. The point is to show you what you can do actually with CSS, okay? Even though it's hard to cover all the performances difference between DOM and canvas, especially for DOM, the thing I really like about DOM is that you keep all the native function of the DOM, like mouse events, text formatting, and you also have SEO, of course, because with Canvas you don't have SEO and it can be painful. So you can always have a fallback if the user doesn't have CSS3 on his browser, for example. So all the examples that I will show you are all CSS3, all coded with CSS3, updated by JavaScript. To create a particle system, you have one particle system as a background. You see with the space invader characters, and we will try to understand how to. We don't really see this, but we will understand how to make it. Then we will see other particle systems. So we will set the area where our particle system will be. I don't have the HTML here, but you will understand that here I'm getting the get element by this stage. So I have a div in my body, and it's called stage. So I create an object called stage, and I select it to set the element of my stage. And I set the color as black to have a black background, and X and Y. In case of you want to move all of your stage, you have to put those properties, but in this case we don't move it, but we leave it. With 200 by 200, it can be the windows in the width or in the height to have a full screen particle system like this one, and an update function that we will run just once to update everything. Oh yeah, put the window in the width in the bottom. And when I update the stage, I have this element.style.top, so I'm updating the CSS with JavaScript. And all the stage will be set like this. So at this step we have a background, black background with nothing inside it. Then a particle. I will create it as a class, but it's an object. And I will set the properties like X, Y, the width, the height, and the maximum speed, because you can have a lot of different speeds depending on the particles. It will render an animation like this, a particle going faster than the other. And velocity is the speed plus the direction. When you say I'm going to that speed, we don't know where you are heading to. So velocity is speed with a direction. And the color of our particle yellow. And we will append the particle to the stage. You can see at the bottom of the line, parent append child. it's because when we will call the particle to happen to one element, we will set append it to the stage. We can have a lot of stages and add our particle in different stages to have different effects. But on those examples, I will show you with one particle system. Then we will create one element, one div, and we will apply it the top as the y-axis and the left as the x-axis. We will set the width, the height, and the position absolute, because in CSS you can't move around an element if it's not absolute. We will see with translation later. And obviously we set the color of the background, and it will be yellow for this case. To create many particles, we will create an array, and inside the loop we will create an instance of based on how a particle we have set it before, this one. This way I put a P in capital letter, it will act as a class, and with object create, we will duplicate an instance of the particle to create a new one, and this particle, we will put it in the center of our particle system, so it will be the stage width divided by 2, so it's the center in x-axis, and stage y divided by 2 for the y-axis, so we have the particle in the center. Random range, it's a function to generate a number between the minimum and the maximum. I have set it on the top of it, of the function, and it will render different speed for x and y, that way the particles will go from different directions. And obviously we append the particle to the stage element, and we push it to the array to be able to update it later. To make them move, it is almost the same process as to create them. We create a loop inside the set interval, and we update the x position by adding his velocity x, and the y position by adding his velocity y. The particle, and then we apply the top and the left positioning, but by math rounding the position x and y. We don't have to math round them, but it's just beautiful when you inspect your particle system. You have rounded numbers and not you see 1.99991. It's just better to do that. So the set interval is 1000 divided by 60. So we are trying to have 60 frames per second, and we'll talk about request animation frame later. And that's basically the way of doing the particle system that you are seeing behind of our code. But you have to know that with CSS3 you have to translate 2D, and it is possible to make the particles move in a 3D space. So we add the z-axis. With the previous code, we just add z, and you can update, translate. So the object x, y, and z. It is as easy as that. And you can add more complex updates by scaling your div and by rotating it. In this example, what I'm doing is I rotate the whole stage, and I move the particle in the 3D world. I don't think they are scaled. No, I generated different width and height for the particles. That way, they are not squared, but more rectangle. And you can have a very complex update by updating the scale x, scale y, scale z, rotate x, and everything, and even the skew. But I don't recommend to do that because it is taking a lot of process to the browser, and it's not, unless you have a good reason to do that, don't. It's as easy as that. And you have many ways to move your particles in CSS. Here I have listed top left, translate 2D and translate 3D. But you have to know that it is also possible to update all the numbers property with CSS. So if I can make my particles move with margin or padding, but it is too slow, so I put them away. According to the JS perf that I have linked, it depends on the browser. Firefox really like Translate 3D. I know that top left is really fast on Chrome, and so you have to adapt your way of animating depending on the browser you are working on. And so we will try to find to see how it works on this browser. I guess it's Chrome, and we have balloons that with a collision detection to the floor. So if it is a basic code to make collision detection, it's not a library at all. I don't use library for the example I'm showing you. So the particle is going down, and when he's more than the stage height, I just invert the velocity y, so you multiply it by -1, and the particles go to the other direction. And to simulate gravity, you don't multiply it by -1, but -9. That way it will go up, and every time you go up, you will not go as higher than before. So here we can see that on Chrome top left it's really fast, and you can see, I will relaunch it. You can see that the balls are turning. And this is because I'm updating the top left position, and then with CSS, not JavaScript, I'm updating with quick keyframe animation, I'm updating the translate property of the CSS to make it rotate. So you can do both. You don't have to animate everything with JavaScript, you don't have to animate everything with CSS. You can do both, but you can't update one property of CSS at the same time as you are updating in JavaScript. JavaScript will take the hands, because if you inspect the elements, you will see that JavaScript is updating the style property right away inside the DOM, and not inside your CSS style sheet. So it will take the hand on your animation that you have written on CSS. You have to choose one or the other. That's why on this example it's really slow, and the balls are not turning because I'm updating the translate property. And this is XY translation, so translation 2D, and the balls are not turning, and it is really slow. Chrome doesn't really like this one. And with this one, you can see that it's really smooth, it's really smooth animation, and translation 3D works very well on Chrome. But translation 3D is not supported everywhere, so you have to test it to see if the animation is working pretty well on the browser you are on. So this is a piece of code I found on the website of Lorenzo Polidori. He's testing if the browser is actually support the translation 3D. So the code is very simple. He's making an object where you can find WebKit, Transforn, Microsoft, Mozilla, and the native Transform. And he's testing over a loop if the element is returning something. If you set a property in CSS to an element, and you write get computed style, and get computed style don't return anything, it means that the browser doesn't support that CSS property, so you can have a fallback or whatever. You don't display the animation at all. And for the frame rate, you can use request animation frame. In the example I showed you previously, you can see that I used set interval. It was just to make the basic one. But with request animation frame, the browser is trying to target 60 frames per second. This is very, with that you have a very smooth animation. So you can imagine an animation made with translation 3D and request animation frame, you almost reach the level of a canvas to animate your deals. And this is a little test that I've made with request animation frame by changing the Z index with CSS. So the particles are moving in a square, and the color is changing, and the Z position is changing with request animation frame. And we have 100 particles moving at the same time. So 100 div updated CC frame per second. It's incredibly fast, and it is insane to see that, because I didn't expect that when I did that test. But you don't have to update your particles like this. If you are a little bit smart, you can guess, well, maybe I can do that with CSS too, an animation like this, because with a little bit of JavaScript, like 3 or 4 lines of code, you can just create your particles and make the animation, for example, with CSS, with keyframe animation. You say from, to scale the particle, you say scale 1 to scale 3, and you create a bunch of particles with different sizes. And here, what you have is all of the particles have different colors when they are generated, but not the same size, but they have exactly the same animation. But as they are created with different sizes, you can see all the particles having their own animation. So it is a really smart way of animating with CSS, because it is not the JavaScript that updates the style property, it is CSS itself. Another example of this. So I create a bunch of particles in the stage with different position, and with a set interval, I'm just updating the top left positioning of the particle, and then with CSS transition, it will make the transition between one point to another. Same here, I create a bunch of particles here, and with keyframe animation, I drew a path 1 like this, and all the particles are just following the path. The thing is, on this example, I created the particles in a square, and they don't receive the class to animate the particle at the same time. That's why they are not, you see there is a little bit late between all the particles. They are not really moving at the same time. Here is an example of another particle creation with delay. So you can see the square rounded adding to each other, and everything is CSS. So as it is animated with CSS, you can, how to get out of here? Oh. Yeah, can you help me, please? Can you remove the full screen mode? Yeah, you can see that the animation is reacting to the size of the screen, because with CSS, if you set the style as 100%, for example, in this one, I think it's 50% of the stage. If you shrink the window, you will see the animation changing. Oof, maybe I shrink a little bit. See? So it's a kind of responsive animation. Everything with CSS. And obviously the weight of all the particles are the same, and they're just different color. And they are not created at the same time. Oh yeah, I really like this one. Because with mouse events, I will create a new particle. This one, the stage is completely empty. And when I move the mouse, I create a new div, and I added a class with, to add the border. And I just update the color with HSL property in CSS3. That way I will have this nice looking animation, you know, as I move the mouse to the, I think like this is better. Yeah. You can play with it for hours and hours. This is, but you have to understand that with CSS you don't really know where your element is, because they are moving with transition, and if you get computer style, computer style is really heavy. Every time you launch it, you will know where the object is, but in a huge frame rate, it will slow down your application or your game or whatever. So, to be sure to know where your object is, you have to update your CSS with JavaScript, and when you know where the object is, you can do collision detection. And here is a basic collision detection. So, as the balls were bouncing earlier, here we are seeing if the particle is colliding to the top, the left, and the right, and the bottom. And when they collide, it just inverts the velocity, so the particles go back in another direction. With just a little piece of code, you can make a game like Pong or whatever. And on this one, it's a little bit more complex because you have friction. You know all this math. When you update with JavaScript, you can do a lot of things like collision, friction, and acceleration too. Because when a particle is colliding to another, you can see it's pushing him and it's continue to forward in another direction. And for this example, I have used HSL2 to have balls with multiple colors, and you can see there is a little 3D effect, or I don't know how to say that. It's really looking with the shadow on the ball. It is actually a PNG that I put on the top of the ball, and with thanks to that, I have different colors. And obviously, if you can calculate everything, we can simulate gravity. As I said, I don't use any library, but if you understand the basic way of faking gravity, you just add to the speed, the velocity y, another force to push the particle down, and you have this little cascade pixel. And obviously, if you invert the gravity, so you, instead of pushing the particle down, you make it moving up, you can have nice bubbles. I like this one. And this is a more dreamy thing. You have snow falling, and this is because to my gravity, thinking of gravity, I added math cos and math sine, and when you do that, you do a bunch of tests, you know, to update your particles. You can have this curvy way of falling, so the particles are not moving in a straight way now, and some of them are. I missed it. Another one, I missed it too. Another one. Yeah, sometimes you can see them hesitating a little bit, going up and going down after. It is really nice. And I wanted to be able to calculate the angle of my particles, so I made this example to show you that it is possible for you to really have a really nice animation with gravity. So it's like a curvy path, and I calculate the angle of the particle at each frame. That it allows me to follow the path and to have a really nice animation. This one is based on the previous one, but I did it with fonts, so I called it Fontaine. This is a trial of using a lot of huge property of CSS. It is box shadow. When you do a box shadow, you have you can set the color, so I set it to red, and you can see that the animation is starting to be very slow. It is because the browser needs to render it, and when you have, for this one I think I have 80 particles or something like this, it is a lot of work for the browser to render such an animation, but it was a cool test. And we have some new properties with CSS, it's blur. And if you add some blur, you have some kind of fire that's coming up. I should improve it a little bit to make smoke or something like this. And you can see the animation is really slow because for the browser to render a blur div, it is taking a lot of resources. Also a little bit of love. And you can, on this example, the how CSS made, it means that it's not PNG file. There is a website called CSS Shapes where you can find shapes like this to not use images. So it's a pure JavaScript and CSS animation. Here it's now I will talk a little bit more about math animation because they are my favorite one. With math animation you can really play with your particles because math formula are almost everywhere. On this example, the particles are moving so fast that you have the feeling that they are moving inside the square, but they are not, they are just moving in the curvy way. But you have like 200 particles moving at the same time and changing color, so it's really fast. Here I call it the universe because all the particles are moving like this, like a solar system. And I added a little glow, so a rock shadow on each particle with a border radius of 50% to have them rounded. And yeah, it's kind of cool to have the universe made with CSS. Then a more atomic one. Yeah, the particles are moving like this. It's always math sign and math cos multiplied by 4, by 5. You just have to test some math formula you can find on Wikipedia, and you can see what it will do. Here we have a feeling of, how to say, rays, but it is not a 3D space, it's 2D space. Again, with math sign and math cos, you can render that feeling of fake 3D. All the particles are just aligned to give you that feeling that they are coming from the center and going to a certain point when they are not. And for this one too, I called it the hourglass because the particles are, if you look very well, if you just take one particle, you will see the particle going from left to the right, but they don't have the same speed, so you have the feeling that they are turning inside a kind of cone. Here we can see it better, because if you look at the bottom, you can see the particle moving like this, but if you look at the middle, you have the feeling like they are turning around. On this one, inside the tornado. Yeah, it's almost hypnotic. And you can fake, yeah, something like the sun. For this one, all the particles are just moving around each other, but as I said, you can animate the whole stage, so I make the whole stage turn with CSS, so I gain performances. On this one, it looks like tentacles, you know. And I really like this one because I found it by, at one moment I had the crazy idea of multiplying math cos by math cos. So it is giving another kind of animation. It was like, whoa, it's superb. Let's do it with math sign and multiply that by math sign. And you have, the more math formula you write, the more complex animation you get. And I can't even explain this one. I don't know if you can see it actually, because on this angle I don't see it. But you can have a very good animation. And this is one of my favorites because I call it the pretzel, and I like pretzel. And it is moving like a snake like this, and all the particles are going like this. But it's not a 3D space at all. Everything is in 2D with X and Y positioning. This one is really beautiful. It's like wings, and yeah, it's almost poetic animation. And to finish with the math animation, I got this crazy idea to make transition between one particle system to another. So by multiplying a function by, let's say, 1 to 0, it will shrink down the function. And if you multiply it by the next function from 0 to 1, it will do like this from a function to another, and that way you have a transition between one particle system to another particle system. And the thing that really astonished me, it was all the particles are made with HSL, and they are spreading to give you a nice gradient all the time. When I did this, I was, wow, it's so fucking cool. And obviously you can do special effects. Here is the solo in the backup in the stars. You have, it's a PNG file with transparent zone, and I'm just adding my particle system in front of it, and they are moving the z-axis. And what are they looking at? Yankat, obviously. So we can see that we can add some animated GIFs, a lot of animated GIFs. And here we have two particle systems, one going from the left to the right, and the other are the little stars that you can see going from the left to the right, and the right to the left. And for this one, it is a huge animation with CSS too. It's when I move the mouse, the tunnel will change. We'll try to go up, yeah. So it is this with border radius, box shadow, and a dotted border. So they are all coming in the z-axis. And on this one, I have a particle system in the middle. You can see little stars coming. And everything is really heavy to animate, but it is cool to see what you can do as a special effect with CSS. Oh, you see this thing? Oh, this is how to render. Wait for it, wait for it. This is an animation. You should see the background moving. Oh yeah. So, this is an animation with 1, 2, 3, 4 particle systems running at the same time. One will have the little stars. The second one is the yellow stars, and the third one is all of my Twitter followers. And if we over them with the mouse, you can have the name, and if you click on them, you will go to that page. So everything is updated with CSS, and this is a really nice animation because I don't have to make it with WebGL or with canvas. And it's not interesting. So Yeah, if you want to learn some basic animation with CSS and JavaScript, there is a really nice tutorial from Christian Hillman that shows you how to update everything in 3D, a 3D space, to understand everything about maticos and mass sign. That way you will have, you will be able to make awesome animation with JavaScript. And there are also libraries, because I told you that I'm not using libraries for my examples, but I know how to use those libraries. JSAP is really cool because it allows you to animate any property in CSS that can be updated with numbers. Sprite 3D by Bob Lamarin. It's this library to make 3D animations with CSS. Really nice library. Game Query if you want to make games with DOM elements. And Box2D if you want to manage physics, real physics this time, not just bounty things, but collision detection and everything. It's really it's the best library you can find, I think, for collision detection with games. And you remember this this particle system I showed you? It was actually a game. And all made with CSS, obviously.